The topic we'll be discussing in this lecture is how computers evolved over the past few decades. So, sorry. First, we'll be discussing the historical perspective of the computer, like how it has evolved in the past 3-4 centuries, very briefly. And then we'll be discussing different generations of computer, uh, which is categorized under 4 generations. First, let us go through the historical perspective. Today's computers, whatever we are using, actually it is developed over the past 60 to 70 years. But if you go back in the history, computers get evolved slowly from mechanical calculating devices. So in the mid of 1960s, complex mechanical devices, which includes gear wheels, levers, pulleys, all these some complex mechanical devices were constructed with these basic parts, gear wheels, levers and pulleys, and they were used to perform, and these mechanical devices were used to perform basic arithmetic operations like addition, multiplication, subtraction and division. And so these are the what you call the very oldest form of computers. And in these devices, the outputs were will be through punched cards or printed on papers. There will not be any display kind of devices. Right? Later, electromechanical relay devices were used for performing logical operations. And the first electronic computer used vacuum tubes for performing logical operation and to store data. And this was actually it was created by University of Pennsylvania, and also it is used in the Second World War. This first computer which uses vacuum tubes, it was used in the Second World War, uh, and and it uses radios and is used for radios and military radar equipment. And this computer, this first electronic computer, which used vacuum tubes, that marked the modern era of digital computers. Okay. So with this brief history, uh, let us try to understand the various generations of computers. So the first is the first generation computer. The first generation computer is the one which used the vacuum tubes. So this was the period from 1945 to 1955. Before that, computers were using, I mean, those were mechanical devices which were using these kind of gear wheels, levers, and pulleys for performing basic operation. The first computer that used vacuum tubes was in the early 1940s. And also along with these computers, the concept of stored program concept was introduced. So what is meant by stored program concept? Stored program concept is something which is introduced by John von Neumann, which means that it's the concept of storing program and data in the same memory. Okay, so there will be a main memory, and in this same main memory, both the program and the data will be stored. Okay. So before that, before this concept was introduced, uh, in computers they were using two memories. One was used to store only program, and the other memory was used to store only data. Okay. So because they don't want to club memory and data. I mean, programs contain instructions, and data are the input or which is used for calculation or whatever it may be. So John V. Newman is the one who suggested to go for stored program concept. Okay. So that in today's system center, what we have, we divide the memory into different section: code section, data section. Code section will contain only the instructions, and data sections will contain the data. So this concept was introduced in the first generation computers. And assembly language programming was also introduced. And with the advent of vacuum tubes, basic arithmetic operations can be done at a very faster speed. That is, it can be done in few milliseconds. Whereas prior to these first generation computers, there were mechanical computers or electromechanical computers, which takes few seconds to perform basic arithmetic operations. So there is an improvement in the speed of 100 to 1000 fold when compared with electromechanical technology. And these computers used uh, one type of main memory, which is called as mercury delay line memory. And for storage purpose, they used magnetic core memory and magnetic tapes. So this is the a brief introduction about the first generation computers. Then coming to the second generation computers, this is during the period 1955 to 1965. During this time, transistors were introduced. Transistors were first introduced by AT&T Bell's laboratories, and these transistors replaced the vacuum tubes, which is used in the first generation computers. So in the second generation computers, transistors replaced the vacuum tubes, and high-level languages like Fortran were, were created. Compilers, so because if high-level languages were there, then obviously there should be compilers which will compile these language into object code. So this kind of compilers were also used. IO processors were developed. IO processor means IO controller. So now if you see, if you have a hard disk, the hard disk will have hard disk controller. Okay, so the hard disk controller is the one which performs read and write operation on the hard disk, or any operation. So if processor wants to perform some operation on the hard disk, processor will not do it by itself. It will just give a signal to the hard disk controller that will do. Okay, but before to second generation computer, that is not the case. There is no such controllers in the IO devices. Everything the processor has to do by itself. Okay, so nowadays if you take any device, so if you take a printer, there will be a printer controller. So the processor is to only signal the printer that do this. Okay, and if you take a keyboard, there will be a keyboard controller. But prior to second generation, these controllers, there will not be any controllers in any IO devices. So these controllers were introduced. These controllers were also called as IO processors. Okay, so they are called as generally they are called as controllers, but you can also call it as IO processors because they are basically processing units. And during this time, IBM emerged as the greatest computer manufacturer. That's it about second generation computers. Coming to the third generation computers, the concept of integrated circuits were introduced, by which many transistors can be fabricated on a single chip. Because of this, the cost of the computers were reduced, and faster processor and memory were developed. And the concept of microprogramming, parallelism, and pipelining was introduced. The microprogramming is the one which guides the processor, like how the machine instruction should be executed. So when you write a program either in high level language or assembly level language, after compiling, it will be converted to machine level language. How this machine level code should be executed, that will be defined by the microprogramming. And the concept of parallelism, parallel execution, and pipelining, that is pipelining means overlapping executions of different functional units. Those concepts were introduced. And during this time, operating systems were developed so that system resources can be shared effectively. And the concept of cache memory and virtual memories were introduced. So cache memory As we know, it's the high speed memory which is placed between the main memory and the CPU. So because of the cache memory, the end user will feel as if the main memory is working fastly. Okay, because most of the frequently used data will be available in the cache memory. So cache memory, basically what it does in the sense, it makes main memory appears faster. And virtual memory, what it does in the sense, it makes main memory appears larger. With the concept of virtual memory, there is no you the processor will never feel there is a lack of memory, whether there is sufficient memory or not. With the available memory, the program will be loaded and then it will be swapped depending on the requirement. So the third generation of computers, that was during the period of 1965 to 75. Then fourth generation, 1975 to present, whatever the computers were evolved, all these comes under fourth generation. So by this time, the concept of VLSI was introduced, which used tens of thousands of transistors in a single chip, and 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 processor. We are able to keep the processor in a single chip. So that concept is called as microprocessor. So before that, before fourth generation, microprocessor is not in a single chip. Microprocessor may be taking a big board. It is not a single chip. Okay, the entire motherboard kind of thing, the microprocessor may take that size. But with the advent of VLSI, the CPU becomes so small. It, and the concept of concurrency, pipelining, cache, virtual memory, all these things keep evolving. They were introduced in third generation, but with technology improving, these concepts were also evolving, and computers started becoming very small. So we have portable computers like laptops, desktops, workstations for performing some powerful graphical related things. There were LAN, WAN, local area network, wide area network, the availability of World Wide Web and Internet starting from mid 1990s. Okay. So mostly the computer size is getting reduced. So before fourth generation, the computers used to be very big. Nowadays, centralized computers or big mainframes were used only for business applications by huge organizations. So this is about the various generations of computers. So if you see the evolution of computers in terms of performance, uh, when there is a shift from mechanical and electromechanical devices to vacuum tubes. So before vacuum tubes, electromechanical and mechanical technology was used for performing arithmetic operation. During the shift from mechanical and electromechanical to vacuum tubes, the speed of the devices increased by 1,000 folds. So when you use mechanical or electromechanical technology, we are able to perform one operation uh, in once in few seconds. Okay, but uh, but with the introduction of vacuum tubes, the same task we are able to complete in few milliseconds. Okay, so the speed increased from second to millisecond. And with the advent of IC technology, the speed further increased from millisecond to microseconds. So again, there is a 1,000-fold improvement. And with the advent of VLSI, the speed further increased from microseconds to nanoseconds. So again, there is a 1,000-fold increment. So this is how the computers are keep evolving over a period of time. So that's it about the history of the various generations of computers and how computers evolved in the past 60 to 70 years. So thank you.